Hello, sixth grade. Good morning. I guess I should say morning. Maybe some of you are sleeping in till like noon and it's good afternoon, but whatever. It's good to see you. Wish your little faces were in here when I'm doing this, but oh well. Anyway, today, lesson 84, algebraic terms. So I would highly suggest you read through your book. This lesson has a lot of information. I hope you're taking notes. Sometimes writing things down really impacts your brain, help it to stick. So polynomials is a fancy word. It means that it's algebraic expressions that can have 1, 2, 3, or more terms. Okay, there's no limit. Basic algebra that I'm going to teach you right now, you're going to know 3 of them. Okay, a monomial, like monocle. That mono means one. Mono. Okay. So this would be a one-termed expression, okay? And something like 3x, right? Negative 7x squared, or to the third, whatever, okay? You could have a variable and a number. Could be positive, could be negative, could be a fraction like 1/2 x to the 5th. That's still a monomial, okay? A one-termed expression. Nothing's getting added or subtracted to it, okay? All right, then we would have binomials, okay? So binomials, like a bicycle, we know that's two-termed expression, okay? So like x plus y. Something's added together, right? Or we could have like negative 5x squared minus x. That's still a binomial because these are not like. Remember when we talked about like terms in the past, we said exactly the same letter and exactly the same exponent. So this has an exponent of 2. This has an implied 1. They're not like. All right? So these would be examples of binomials. All right, and then you also have trinomials, right? A 3-termed expression. All right, like x squared minus 2x plus 1. 3 different terms. Nothing's like. All right. Now there are, of course, 4-term, 5-term. We don't have names for those. We're just going to talk right now about monomials, binomials, trinomials, and we know that there are more, but these are the names that I'm interested in you knowing right now. All right, so what you're going to do after you've read through page 581, I also want to remind you that a constant term would be like this one right here. That's not for you. Don't leave. All right, so this right here is a constant. It doesn't change because there's no letter right there, okay? So like if I have 5x minus 2, the negative 2 is a constant. It doesn't change. The variable is the letter. The number in front is the coefficient. We've already talked about that. That should be in your notes. All right, so what we're going to do first of all is determine whether things are monomials, binomials, trinomials. So let me just write up here. Okay, so what would this be? A trinomial. Very good. How about this? Binomial. Very good. And this one? It's a monomial. It's multi-term, multi-variable, but it's only one term, okay? Everything's getting multiplied together. It's not something plus something or something minus something. So monomial, binomial, trinomial. All right, now let's also do example 1. And this one is on page 582. And it says, use the commutative and associative properties to collect like terms in this algebraic expression. So the reason they're saying use commutative or associative is that we could regroup, we could change things around. But I'm just going to say to you, go ahead and look at it and see what your like terms are and combine them. All right? That's you've used those properties. You just didn't have to write it out step by step. So does everybody see that a 3x and an x would be considered like terms? We got the same variable and the same exponent. So if you have 3 x's and I give you an x, how many x's do you have? 4x, right? There's an implied 1 here. So 3 plus 1 is 4x, right? 3 apples plus 1 apple is 4 apples. Now, we also have a y and then a minus y. Well, what happens to those? If you have a y and I take 1 away, how many do you have? No y's. So, combining like terms with this problem, you would get 4x as your final answer. All right, let's look at example 2. We have 3x plus 2x squared plus 4 plus x squared minus x minus 1. All right, so let's work with the highest exponent first. Let's see that 2x squared and an x squared. Those are like, aren't they? So if you have 2x squared and you add an x squared to it, how many do you have? 3, right? So 3x squared. And if you want to, you can cross those off. You've combined that part. Now, you have a 3x now, and over here's a minus x. So 3x, take away x, 2x, right? Okay, so now we've taken care of the x's. Now I have a 4 minus 1. What's 4 minus 1? 3. So here's my answer. This is what we call descending order because I started with my highest exponent and I'm going down, right? 2, 1, no exponent. But we'll learn more about that later, but this is the best way to put your answer. It really doesn't matter if they're out of order as long as the signs are correct, okay? And your coefficients, the numbers in front of the letters are correct. And this answer is a trinomial. Very good, very good. All right, so it's time for you to do the practice. Stop the tape, do the work, and then check your answers. So for A, you had a binomial. I don't mind if you just put a B. For B, you had a trinomial. T is fine. C, you have a monomial. And D, a binomial. Remember? 2 terms, 3 terms, 1 term, 2 terms. Okay, that's what you're supposed to do for E. All right, F is over here. I had 2a squared and a squared gave me 3a squared. 3a minus a is a 2a. All right, for G, we have 5xy and xy. So 5xy and xy would be 6xy. Now here you have to be very careful. Do you see you have a minus x and a minus 2x? Remember what subtraction is. If you start out with a minus and you're taking away, I'm going to suggest that you remember what subtraction is, adding the opposite. So I'm adding 2 negatives. Therefore, this is a negative 3x. Okay, if you're having trouble with that, go back through. Look at the example. Call me if you need some help, okay? On H, I combined the x squared and the 2x squared, got 3x squared. There's only one x, nothing else to combine, so that needs to be in my answer. Then negative 5 and a 3, or 3 minus 5, however you want to look at it, is going to be a minus 2. Okay? Again, if you have trouble with this, give me a call. And then I have 3 pi plus 1.4 minus pi plus 2.8. So the 3 pi and the minus pi, those are like. That's like saying 3x minus x. So if you have 3 pi's and I take one away, you have 2 left. That'd be kind of fun. Take a whole pie. All right, and then a 1.4 plus 2.8, adding the decimals, I get 4.2. Okay, so we are done with 84. Consult with RenWeb for your official assignment. God bless you. Love and miss you. Talk to you soon.